Alright guys, so we are going to start writing some equations for basically all the functions we have not already written them for, which is going to be our tangent, cotangent, secant, and cosecant. So we're going to start off with sine and cosine. So if you look at this graph, this looks similar to the tangent parent function. So we're going to write this graph as a tangent graph, and we're going to use that same equation we've used, and we're just going to fill in all four of those different parts. So we're going to start off with C, which we've done a lot already. C is still the height of my middle, and the height of my middle points in this graph. Here's a middle point. The height of that point for my C is 3. Then to get my A, my amplitude, that's that distance between my middle critical point and that next high critical point. That height difference right there is 2. So that's my A. Now B is a little bit different. So if you remember, the tangent parent function has a period of only 1 pi. So B is going to be 1 pi divided by my period. Or it's going to be 180 divided by the period. All right, then finally what I'm going to have, or actually let's go ahead and find that, sorry. So the period is however long it takes to repeat itself. So if I start over here at this asymptote, that period is going to end over here at the other asymptote. So that distance right there, that distance of the period is 12. So that means that my B is going to be pi divided by 12. And then the last one is going to be my shift, which is my D. So if this is a tangent graphs start in the middle. So D is going to be where I've shifted a middle point to. So if I look, I've got a middle point right here at a value of 2. So that's going to give me x minus 2 in my parentheses for my D. So one way I could write this whole equation is y equals 3 plus 2 tangent pi over 12 times x minus 2. Alright, however, there is one other way I could write this. If I chose, I could have written this as a cotangent function. And there's going to be a few changes. If I write this as cotangent, one change would be, it had to do with what that parent function looks like. So if you think about the cotangent parent function, it looks like this in between my asymptotes. So that means in order, what I'd have to write for this one is I would have to write it as a reflection. So instead of writing it as 3 plus 2, I would have to write it as 3 minus 2, because that graph goes in a different shape if I change that to cotangent. But my A, B, and C will not change. Just like sine and cosine, A, B, and C stayed the same. What's also going to change is my shift. So if you think about cotangent, cotangent shifted an asymptote. So the location of D would have to be either x plus 4 or x minus 8. So if I wanted to write that as a cotangent function, I could. I would have to realize that that's a negative. It's a reflection because it doesn't have the same shape as the parent function. Alright, so now we're going to do one that actually looks like a cotangent function. So that's this graph down here. So if I graph this one, I'm going to do it the same way. I'm going to use that same function, C plus A, but this time I'm going to do cotangent because it resembles the cotangent parent function. And I'm going to find all of those parts. So let's start with C. Height of the middle is 3. A, the height difference between the middle points and the high points. That height is 2. B, I need to find my period first. So the period is the distance between the two asymptotes. That period is 4 pi. So B then is 1 pi divided by 4 pi, which ends up being 1/4. So that's my B. And then D for cotangent, remember cotangent, we just talked about this in the last one, cotangent is a shift of an asymptote. So the asymptote that I'm shifting here is either at pi, or 5 pi, or 9 pi. But let's just go ahead and use the easiest one, which is going to be x minus pi. So this whole equation is going to be 3 plus 2 cotangent 1/4 x minus pi. All right, the last one we're going to do is we're going to do secant and cosecant. Now, secant and cosecant aren't going to be very difficult if you remember sine and cosine. But what's very important about this, if you guys look, there's that little dotted line in between there. And that little dotted line, if it's not there, make sure you draw it in. Because that little dotted line is our guide to draw our graph, but it's also our guide for how we write our equation. Because if we have that dotted line, it's the exact same as we've done for secant and cosecant. As long as we remember that 1 over sine is equivalent to cosecant, and 1 over cosine is equivalent to secant. We're going to write this equation. We're going to do y equals still c plus a, cosecant or secant, times b, times x minus d. So let's find those things. C is my middle height, okay? This middle height, if it's not drawn in, it's halfway in between the highest, or halfway between the lowest point here and the highest point here. So for this case, my C is at 4. Amplitude is still the amplitude of the wave. Whoops, I don't know why I'm writing an A over there. Amplitude is the distance of that wave, or it's the height right here. That's my amplitude. So in this case, that's 6. B, I still need to know what the period is, but we're back to using 2 pi because the parent function for this one is 2 pi. So let's say I start here at this point. In order for this graph to complete one full cycle, it's not at 2, it's all the way over at 4, because a full cycle is an up and down parabola. I need both of them. So that means that my period is a distance of 4. That means that B is 2 pi divided by 4, which is pi over 2. That's my B. So finally, all I'm left with is my D. So D, again, is a shift. But if you remember, that's going to depend if it's secant or cosecant. So if I do cosecant, cosecant is like sine. And sine shifted a middle point. So I would look for a middle point in this graph before it goes up. So that would be like right here or right here. So if I write this as a cosecant, I can do x minus 2. Or I could do x minus 6. Right, the other option, let's say I want to write this as a secant graph. If I write this as a secant graph, I'm looking for a high point because secant is like cosine, and cosine's parent function goes to the top. So I could write it like that. So my high points are -1 and 3 and 7, so I could write that as x plus 1, or x minus 3, or even x minus 7. Whoops. But this full equation, fully written out, would look something like this. And that's it. If I wanted to, I could change that to secant, make it x plus 1. But again, the only thing that would change is my D. A, B, and C will not change no matter what kind of graph I'm drawing. And that's all there is for writing equations. This is the last new thing before you guys have your test.